Artificial intelligence, it's kind of everywhere, right? And it seems to bring up these two huge feelings at once. Incredible excitement and, let's be honest, a whole lot of confusion. We keep hearing it's this revolutionary new tool. But what kind of tool is it? Is it one we can trust completely, or is it something else? That's what we're going to dig into.
And really, it all boils down to this question. Are we dealing with the super smart, reliable calculator that just helps us out? Or is it more like a buggy computer program? You know, the kind that crashes and you have no idea why. Because how you answer that really changes how you should be using this stuff. So let's start with some practical advice.
First up, there's a really popular guideline floating around that can help keep you safe. It's called the 30% AI rule.
It's a pretty simple rule of thumb. Basically, when you're working on something, could be a school paper, a report for work, anything, the idea is that only about 30% of that final project should come directly from an AI. This chart makes it super clear. The lion's share of the work, that big 70% chunk, that's still you. It's your ideas, your research, your brain power. The AI is just there to give you a boost, not to do the driving. And that gets to the absolute core of this idea. Thinking of AI as a tool, never a total replacement. Probably the best way to think about it is like a calculator. A calculator is amazing for doing heavy-duty math, right? But it's totally useless if you don't actually understand the problem you're trying to solve in the first place. You still have to bring the knowledge. Well, AI is pretty much the exact same deal.
And when we use it the right way, man, the benefits are huge. It can get you unstuck when you have writer's block, take care of all those boring repetitive tasks, and even help you learn by giving you instant feedback. It really can be an amazing collaborator.
Okay, so a rule like keep it to 30% seems simple enough. But here's the twist. What if the very reason we need a rule like that is because most of us are making a giant, fundamental mistake in how we even think about AI? This is where it gets really, really interesting.
Let's talk about the software we've all grown up with, and why our ideas about it are leading us completely astray when it comes to AI.
You know, for decades, we've been trained to think about software in a very specific way. It has bugs, right? And we know those bugs are put there by a person, so another person can find them and fix them. We just assume AI is the next step, but that assumption, it's just flat out wrong.
And this quote just nails that assumption perfectly. It sounds so logical, doesn't it? If the AI messes up, some genius programmer can just pop the hood, find the broken line of code, and patch it up. But with modern AI, that's not how it works, not even close.
So if that's not how it works, then how is AI so different from every other piece of software on your computer? Let's break it down. Okay, so look at where bugs even come from. In your regular software, a bug is a mistake in the code. Someone typed something wrong. But with AI, the strange behaviors, the bugs, they usually come from some weirdness buried in the mountains of data it learned from.
And how big are these mountains of data? Get this, to read through just one of the popular datasets used for training, it would take a single person over 85,000 years. No, that's not a typo. The scale is so gigantic that no human being could ever really know everything that went into it.
So what about fixing things? Well, in regular software, a programmer can trace the problem to an exact line of code and fix it. It's logical, it's deterministic. With AI, you can't do that. Researchers can't go in and find the error. All they can really do is show it a bunch more data and, well, hope it learns to behave better. It's probabilistic. It's a game of odds, not certainties.
And this, right here, is probably the most important thing to understand. When a normal program crashes, you can figure out why. You can trace the steps. When an AI makes a mistake, nobody, and I mean nobody, not even its creators, fully understands the step-by-step logic that led to it. It's a black box.
Which leads to another idea that'll kind of bend your brain. With old-school software, you can tell it exactly what to do and what not to do. But with AI, you can't. You can give it a goal, like get really good at understanding human language, but you have no real control over all the other skills it might pick up along the way. And sometimes these surprise skills are incredible. There's a famous story about an AI that was released to the public, and months later, people figured out it had somehow taught itself to be a world-class player at the online game GeoGuessr. Its creators didn't even know it had that skill. Now, that's a really cool discovery, but it forces us to ask a much more serious question. It's one thing for an AI to be secretly good at a geography game, but if we can't predict what skills are going to emerge, what happens when the next hidden talent isn't quite so harmless? So, what does this all mean for us? Where does this leave us?
Let's try and connect all these dots and figure out what it means for our future with AI.
And this brings us right back to where we started. That 30% rule? It's not just some random number. It exists for a very specific reason. Because AI is not like regular software. We can't treat it like a predictable, perfectly reliable machine. We have to treat it like a powerful, but also unpredictable partner in our work.
So what we really need is a whole new mindset. First, we just have to accept that AI is built on a totally different foundation. Second, we have to get comfortable with the idea that its behavior is based on probability, not predictable logic. And that means third, our job isn't to wait for someone to fix the bugs, it's to learn how to use and interact with these things responsibly.
And that leaves us with one last massive question to chew on. If there's no simple bug to patch when things go wrong, if we can't just look under the hood and fix the problem, how does that force us to change everything? How we build these systems, how much we trust them, and, at the end of the day, how we decide to live alongside them?